Okay, number 2, we're given this rational function. We want to find this information, and then we're going to put it all together in graph. Okay, so we're going to follow kind of the same procedure we did for question number 1 when we had to do the other one. For this one, by the way, number 2, you're not going to have to worry about graphing a slant. Okay, so number 1 is going to have that slant in it, but number 2, you're just going to have a regular horizontal asymptote. So you want to make sure you understand your horizontal asymptote rules. In that case, that has to do with the highest power on top and the highest power on the bottom. You want to know those for horizontal asymptote. Okay, so let's go. Let's start with x-intercept. So x-intercept, actually you're going to do y equals 0 is what you can use, but let's instead think about it this way. For x-intercept, it's always going to be the top equals 0. Okay, so the reason why we always say the top equals 0, by the way, is if we put a 0 in for the y and cross multiply, we'd end up just having the top equals 0 anyway. So this, in a way, is kind of like a shortcut, so that way we know what to do every single time. So if we do x-intercept, set the top equal to 0, we get x is equal to 2. Okay, so for this, that's going to be our x-intercept. That's where it crosses the x-axis, crosses at 2. Next, let's do y-intercept. That's where you put in a 0 for x. I'm going to put zeros in for all the x's. So basically you can just get rid of all the x's. Now you're going to be left with a -2 over -3. So that's going to give you -2 over -3, which negatives cancel and you get positive 2/3. Always make sure you get rid of double negatives when you have those. So 2/3 will be, that's where it crosses the y-axis. Next, let's look at the VA. Okay, so VA, up here, VA is, to do that, you take the bottom and set the bottom one equal to 0. So I get x squared minus 2x minus 3 equals 0, and then I'm going to factor this one. So this one I can just do normal factoring. Factors of the last number that add up to the middle number, and when I do that, it's going to be 1 and 3. I'll have to have the 3 be negative, so that way I get the middle term to be negative there. We're going to set both of these individually equal to 0, and we get -1 and +3. So -1 and 3. Now remember, don't put your answer like this on a test. If you put your answer like that, it's going to be marked wrong. There'll be some point taken off for that. Because, remember, vertical asymptotes, you need to put x equals. Now, it's okay to write your answer like this. So you can put x equals -1, 3, that's fine. When you entered it in online, usually it asks you to put in a comma in between your answer. But on a test, if you write your answer like this, it's okay. As long as I see an x equals somewhere in there, then that's fine. Now, horizontal asymptote. What I'm going to do is I'm just going to put rules here for that one, because there's a couple different rules that I talked about in the lecture notes. So that has to do with the highest power on top, which is n, the highest power on the bottom, which is m. So in this case, I have the higher power is on the bottom. So what this actually says is this. It says that the highest power on top is less than the highest power on the bottom, n is less than m. So when I have that situation happening, that means there's exactly one horizontal asymptote that works for this, and automatically it's y equals 0. So there's not really any work you have to show for this one. Whenever the highest power on top is less than the highest power on the bottom, automatically your horizontal asymptote is going to be y equals 0. So again, make sure you put the y equals there as part of your answer. Now the other rule that we have is if you have the highest power on top is the same as the highest power on the bottom, then basically what you do is you divide the numbers in front of each of the x's. So if the top one, let's say the top one was a square, for instance, you'd have a 1 divided by the 1 down here, and your answer would be y equals 1 instead. So you want to make sure you know that rule as well, because either one of those could be on the test. The third one rule is if you have the n is greater than the m, and that's when you're going to have a slant asymptote. So again, that's only going to happen on question 1. You're not going to have that here on question 2. Alright, so now we know all this. Let's go ahead and put all this down on our graph. So first of all, I'm going to take care of the intercepts. It crosses at 2, and the other one crosses at 2/3, which is about right there. I have a vertical asymptote at -1, so there we go. We got a dotted line we'll put in for that one. The other one's going to be at 3, and so I have this one. Okay. So that's all the information that I found algebraically. Now, the center one, we can take care of that right away. We talked about in the notes that in the middle, there's actually these patterns could go in the middle. So they kind of look like this. So in between the two vertical dotted lines, you're either going to have a shape like this where it's a U, an upside down U. You'll have a kind of looks like a cube or reverse cube there, and a positive cube you'll have. So these are the 4 different patterns that you could have in the middle. And so we're just going to look at the information that's given, and sometimes by the information given we can determine which one of these shapes it's going to be. So in fact, the only one of these that's going to match is actually going to be this third one. So automatically I can tell that what's happening in there, it's going to look like this. Okay, so I can tell what's happening in between the two vertical dotted lines. Now, I don't know what it's doing on the ends right here. I could either have a shape like this, or I could have it down below. And same with this one. So if I don't know what it looks like, this is when you want to go ahead and pick a couple test points. So for test points, we want to pick something that is to the left of this line and to the right of this dotted line. So let's test x equals -2. And I'm also going to test something out here. Let's try a 4. Okay, so I'm going to try -2 and I'm going to try 4. I'm going to put these into the original function, work it out, and that's going to give me an actual point on the line itself. So for instance, this one, what I would do is I would put -2 in for all the x's. So I'm going to show that here. And we want to work that out. Okay, so I'm putting in -2 for all the x's. Now if I work all this out, I get -4 on top. On the bottom I get 4 plus 4, 8 minus 3. So I get -4/5 as the y value. Now, as a coordinate, you can actually write it like this. -2 and -4/5 would be an actual point on the line itself. So here, if I go -2 and -4/5, that's about right there. So what that tells me is that the graph is going to have to be below like this. So these kind of graphs, it's either going to be all below like this or all above on the ends. Okay, so that's why I had to do a test point to determine is it down here or if it's up there. Next one, I got to figure out what's happening at 4. So again, I'm going to put in a 4 minus 2 on top, 4 squared minus 2 times 4 minus 3. I'm just putting that into, again, the original function in place of the x's. And I'm going to work all this out. I get a 2 on top, and on the bottom I get 16 minus 8 minus 3. So 16 minus 8 is 8, 8 minus 3 is 5. So I get positive 2/5. Now as a coordinate, I can write that as 4 and 2/5, because 2/5 was the y value that I got from putting in the x value of 4. Okay, so when I test that one, here's 4, and 2/5 is going to be about right there. That tells me now that the other part of the graph is going to be here. It's going to be above. So then this right here would be your completed graph. So this information will help you set it up. You may or may not have to do test points. It all depends on what the original function is. But this particular one, we do have to test the endpoints because you don't have enough information to know whether it's above or below.